Welcome back. This is the third lesson recording for IM1, April 23rd, 2021. Okay, so now we're up to card number 8. Now this time we're being asked to transform the triangle with the rule x, y error, becoming x plus 2 and y minus 2. So think about this. What does that mean? That each of whatever the x coordinate is, all the x coordinate is going to be added to 2. So the new x coordinate is going to be the old coordinate plus 2. So that means x is the horizontal axis. So the horizontal position is going to increase by 2. Okay, so it's going to increase by 2. And the y value is going to be decreasing by by 4. That means it's going to not go up, but it's going to go down by 4. So I'm going to move that 1, 2, 3, 4, 5. It's right there. So that's the new coordinate that corresponds to that original green. And I need to do that with each one of them. 2 to the right and down by 1, 2, 3, 4. 2 to the right and down by 1, 2, 3, 4. Okay, and that's my shape. Okay, let me just check. Oh, I think, did I do it okay? Does not look quite right, right? So, because this is what I'm saying, you should visually check. Does your shape look exactly the same? It should be, the shape should be the same, but it's just the location. Here we go. Let's try this. Okay, so if I move 2 to the right and 4 down, 1, 2, 3, 4, it actually should be here, not 1 down. So there we go. All right, now it looks more like it. That looks like same shape, but just different location. Okay, and I got it. All right, which image is the original? Can you tell which is the original? Is it the blue one or the red one? How can you tell? The one with the prime notation is the new transformed image. So this is new, so that red has to be the original. Notice that M is here, the corresponding M prime is right there. So what is the transformation? Well, first of all, the image, the original is red. Explain your thinking. Well, M does not have the prime notation, or the polygon MATH does not have prime notation, while the blue polygon has the M prime, H prime, T prime, A prime. So I'm going to say something like that. And what type of transformation do you see? Well, I can see that M became M prime right here. A became A prime here. So what do you think? This is a reflection across the y-axis. It's as if I put a mirror right here, then I could see the reflection on the mirror that looks exactly like the reflected image here. So it's a reflection across the y-axis. How do I know? Because M is 3 units away from the y-axis and M prime is 3 units away, but in the opposite direction. And A is 7 units away from the line of reflection, and A prime is 7 units away, but on the opposite direction, to the left, and so on. Okay, now red image is reflected across the y-axis. Okay, so this is what we discovered. It was a reflection over the y-axis. Below are the coordinates, the vertices of the original red reflected in the blue image. So M and M prime. M has the coordinate of 3, 6. M prime has the coordinate of -3, 6. And A is 7, 6, and A prime is -7, 6, and so on. What do you notice about how it has changed between the coordinates? Well, the y value 6 and 6 seems to stay the same. The x value just changed. 3 became -3. 7 became -7. 5 became -5. 3 became -3. So what do you notice? The x coordinate just changed its sign. This value, the number is the same, but it became its opposite. Okay, so if it was positive, it became negative. But the y value, y coordinate stayed the same. Okay, what if it was 5, 5, 5.5, 3 is also part of the red image? Use the rule you just noticed. What would be the new coordinate? Remember we said the x coordinate is going to become negative version of the old x coordinate. So what is negative of 5.5? It's going to be negative 5.5. So it's going to be negative 5.5. What about the y coordinate? That just stayed the same. So it's going to be negative 5.5, comma 3. So let me do that. And 3. Great. And then 13, which of the following do you think is a rule for reflection across the y-axis? Okay, so what do you think? The y stayed the same. Y stayed the same. So y stayed as y. But the x became opposite. So x became negative x is this one. While as x stayed the same here, then y became its negative version. That's not true. Okay? So summarizing the reflection rule across the y-axis, notice that the x-coordinates are the only ones that change to its negative version. Okay, so the new x-coordinate is opposite of the original x-coordinate. Okay, so while as the y-coordinate stayed the same, there was no change. That's what happens when you're reflecting across the y-axis. You might think that the y coordinate would change, but it's actually the opposite, isn't it? Okay, it's the x coordinate that became its opposite, while as the y coordinate stayed the same when it was reflected over the y-axis. So keep that in mind. And so the rule we can say is x became negative version of the old x, and y stayed the same. Y was y after the transformation. All right, so now you're going to be working on card number 14 to 15. Okay, what does the rule do? Number one, Raseki is given a new mysterious rule. X, y became y, negative x. He wants to know what type of transformation this rule makes. He used the rule to compute the transform coordinates. So when you start with 3, 6, okay, so whatever the y was, that became the new x value. So 6 became the x, and whatever the x was, which it, it became the new y value in its opposite form. So x became the y, and taking that negative of it. So let's keep doing the same thing here. So here, the x coordinate is going to be coming from whatever the y coordinate was. What was the y in the old y? Which was 2, comma. And the new y coordinate is going to be whatever was the x, which was 5, but it's negative version of it, so it's going to be negative 5. Okay? And with this, y was 2, x was 3, so negative of 3 is negative 3. Okay? All right. All right, and then we're going to move on. Okay, so now, here we go. Sketch the transform points. So now you're going to draw 6, negative 3. Where is 6, negative 3? 6, negative 3 is right there. That's my M prime. And 6, negative 7. 6, negative 7 is right here. And that's my A prime. And T prime is 2, negative 5. 2, negative 5 is right here. That's T prime. And H is 2 comma negative 3. 2 comma negative 3 is right here. H prime. Okay, now I am going to use my line tool to draw that. Draw the shape. Oops. Let's undo that. Okay, so what sort of transformation is it? Well, it's certainly not a translation. It did not just slide down because it's a different orientation. Okay, is it a reflection across the x-axis? It does not look like it. Is it a rotation? Okay, does it look as if this has rotated? It does look like rotation, and you can certainly check that with tracing paper. Well, actually, it would not quite work because these rectangles are not quite. This should be a square, but it's actually a rectangle, so that's the reason it looks slightly different. But it is a rotation 90 degrees clockwise because went from here. Oops, let me get it moved 90 degrees this way. Okay, so that is rotation. Okay, now last part of the lesson. Reflect the T across the red line. Pretend that you are folding this in half. What happens when you fold this in half? It just matches right on top of each other, right? It disappears. Or if I was trying to reflect the left-hand side, it will be exactly the same as the right-hand side here. Okay, so this is what we call line symmetry. Okay, so or reflective symmetry. Reflection symmetry. And so you're going to do card number 16 to 22. Does this arrow have a reflection symmetry? So to do that, you need to be asking yourself, can I fold it in such a way that it matches the left-hand side with the right-hand side, or up with the down, or, however way it folds over exactly? Yes, it does. If I fold it over like here, then it's not going to match up. But what if I folded it over from here to here? It would. So pretend I'm folding along this line, it would just match up from the top and right, and it would match up perfectly. So that's what we call reflection symmetry. So it has one possible line of reflection. Okay, does this regular hexagon have a line of symmetry, reflection symmetry? Well, can you fold this in such a way it matches up exactly? Yeah, there are many different ways. If I fold it from up and down, the left-hand side and the right-hand side is an exact mirror of each other. Okay, if I folded it from here through these vertices, the left-hand side and right-hand side is exact match. Or if I do the same thing here, cross horizontally, there are many different lines of reflection. Okay, so that's what reflective symmetry is talking about. Is that, can you fold it in half such way left and right hand matches up exactly? What about this? Can you fold it in any way so that it will match up? No, because so we say that it does not have reflection symmetry. What about this? Can you fold this in half? Yeah, I can fold it from top down like so. Is there any other way? I can fold it this way. When I do that, the left-hand side or one side to the other side is looks exactly the same. Okay, and I can do it multiple sides, many different lines like so. What about this? Well, if I fold it here, this would not work, right? What if I fold it across? No, it would not work. What if I folded it at a diagonal like so? Would it work? Yes, it would. And you can use mirrors to check. And what about C? there is no reflective symmetry, and